Hi, welcome to Seeing Calculus. In this video we'll be learning the chain rule. Now the chain rule is our tool in our arsenal that gives us all the heavy-duty firepower to handle those tough derivative problems. So here is where we separate the men from the boys and the ladies from the girls. Just kidding. It's not so bad. You just have to make sure that you're taking your time, you're keeping everything in its right place as to not confuse yourself. Okay? Let's get started. Now the chain rule is used whenever you have a function inside of another function. What I mean is, with sine of x versus sine of x, sine of 2x, and sine of x cubed, they're all different. The ones in red are functions within another function. So here, where we just have a regular function, if we plug this into the calculator and x was 3, we just put sine of 3 into the calculator. We get an answer. However, if we try that here, where x is 3, we'd have to do a step before that. We'd have to do 2 times 3 to give us 6, and then do sine of 6. Same thing here. Where x cubed, you'd have to do 3 times 3 to give you 9, and then do sine of 9. So that's what I mean, a function within a function. And the way you do that is following this notation here. Now this reads the derivative, d by dx, of f of g of x, because f of means a function's inside, and the g of x is inside. The way you do this is you take the derivative of the outside function while leaving the inside function, times that whole thing by the derivative of the inside function. So it's the derivative of the outside function, leave the inside function, and multiply that whole thing by the derivative of the inside function. Here's an example. The derivative of sine of 2x. So first thing we're going to do is take the derivative of the outside function. Notice I put prime here to indicate derivative. I left the inside function, and I'm going to multiply by the derivative of the inside function. So derivative of sine, as we learned in the last video, is cosine. So we have cosine, leave the inside, so we get 2x, times the derivative of the inside. Well, the derivative of 2x, you just cross off this x and you get 2. So you get cosine 2x times 2 is your derivative. And I'll just rewrite it and put the 2 in the front so it looks neater. You probably see it in this format in textbooks. Okay, let's move on. In this example, we're following the same formula, the derivative of the outside function while leaving the inside function, times the derivative of the inside function. So in this case, we have to identify our inside function, which is x cubed, and our outside function is e. Okay, so we're going to take the derivative of e while leaving the inside function and multiply it by the derivative of inside function. So the derivative of e is just e, and leave the inside function, so we're going to get x cubed. So in this case we actually got the same thing, and we're going to multiply that by the derivative of the inside function. Now to take the derivative of this, we're just bringing this 3 down to the front, so the 3 down to the front, and subtract 1 from the 3 to give us a 2 as our new exponent. There's a derivative, like we did in last video. So we just put this 3x cubed, 3x squared to the front, and there's our derivative. Okay, let's move on to the next example. Now, actually, we've been doing something new called the chain rule, but in reality, it's not new. We were doing this earlier, because when we took the derivative of e to the x, well, e to the x, the derivative of that is just e to the x, but it's actually the outside function, e to the x, times the derivative of the inside function. But since the inside function, or the inside item, was just x, the derivative of x is just 1. So that means that 1 times e to the x equals e to the x. So we actually were doing the chain rule the whole time. It's okay if you don't see it. I'll show you another example. Here with sine of x, I said the derivative of sine of x is cosine of x. Well, we did the derivative of the outside, sine of x, to give us cosine x. Then we times it times the derivative of the inside. But the derivative of x is just 1. because x is just 1x, so you cross off the x, you get 1. So in reality we have 1 cosine x, which is just cosine x. So let's skip this step. Okay, now we're going to show you how to do the chain rule while using a u substitution. Now, using the u substitution makes the chain rule a lot simpler, because without it you can get so confused trying to keep track of where everything belongs. And in the last example I showed you today, you'll see how it's easy to get confused. Now, some students, they will not use this u substitution. They think it makes things harder, and they just decide not to use it and decide to struggle the whole time trying to get it on their own. But I highly recommend using this u substitution. So if you learned another method in school, I recommend using the substitution. It makes it a lot easier as you deal with more complex derivatives. Okay, let's go. Now, this is what we had before. F prime of the inside g of x times the derivative of g of x prime, rather. Now, notice, what's the difference between this line and this line? Well, I just replaced g of x by u. So instead of f of g of x and f prime of g of x times g prime of x, it's just f of u equals f prime of u times the derivative of u. So the u replaces g of x. So that's to set us up to use the u substitution. Okay, let's start. So to do this, you'll first have to identify what your inside function is. In this case, it's 2x cubed. Once you identify the inside function, you just label it u. So this whole 2x cubed is just going to be called u. Next, we make a fact box, like what I like to call it. And in that fact box, we write what u is, which is 2x cubed. Then we write the derivative of u, which is going to be 3 times 2, which is 6, and subtract 1 from this 3 gives you the 2. So, and I call it du for derivative of u. Good, so we have our fact box. We know exactly what to do next. Now, I'll tell you, the derivative of cosine is negative sign. You'll understand this when you look at the graphs video later on the website. Okay, so now following the same rules for the chain rule, we're going to take the derivative of the outside function, leave the inside function, and then multiply by the derivative of the inside function. So in terms of u, it's going to be the derivative of the outside function and leave u as it is, then multiply that whole thing by du. So let's go. The derivative of cosine u is negative sign, and we leave the u as it is, and we multiply that by du. So this is our answer. Now we go back to our fact box and we just plug in. So what was u again? Ah, yes, here's u, 2x cubed. So we plug in 2x cubed right here where u was. And what was du again? Oh yes, 6x squared. We plug 6x squared right here. Now that's a simple example of how powerful using the u substitution can be. It makes it a lot easier to work with, especially when you have hard problems that have a lot of steps. Let's look at another example. Here's the example I was talking about. They called it y prime. So I'm just switching between notations. Earlier I used d by dx, the derivative of the function. I used f of x to say what's the function. Now I'm using y. You might find this in a textbook, you might find this one in a textbook. They alternate between the different notations. So they're saying y equals 7x plus sine x, and then that whole thing is cubed. Wow. We're going to have to try and find the derivative of that. So find y prime. Well, good thing we have our u substitution. So the first step is to identify what is the inside function and what is the outside function. Here it is. The inside function is this, 7x plus sine x. And the outside function is this 3. So we make a fact box, and u equals to 7x plus sine x, because we're just stating what we know. This is our u because that's our inside. Now what's du? Well, to figure out this du, we'll have to use the addition rule for derivatives. So the derivative of 7x, you just cross off the x, is a 7. And the derivative of this sine of x is just cosine x. And remember, since it's just addition, you just add the derivative of each. Okay? So now let's identify. Now that we've identified what a u is, our new function looks like this. Instead of y of all of this stuff cubed, it's just y of u cubed. That's the power of u. It replaces all this junk by a single letter to keep your mind straight and focused on what you have to differentiate, because all of this can easily confuse you. So now we have y equals u cubed. Well, from our earlier videos, you can easily tell me what the derivative is. It's going to be 3u squared, because you bring down the 3, then you subtract 1 from the old exponent to make it a 2. But one thing I didn't say before that we were doing is that we're multiplying by the derivative of u. Now, because u is a function in itself, the derivative won't just be 1. So here's the derivative that we stated before. So this is our answer, because we just did the derivative. It's 3u squared times du. All we have to do now is just plug in. Okay, so what was u again? I can't remember u. Oh, here's u. It's 7x plus sine of x. So it goes right into here. You notice the squared is here. So all I did was take this right here and substituted it back in for u that was right here. Now times du. What was du? Oh, it's right here in the box. Okay? I just substitute du in right here, and this is our answer. So in the original question, when they gave us this monster of an equation and said find y prime, well, we gave them an even bigger monster of an answer, and this is y prime. Teachers and textbooks can give you some very difficult examples. They could even be crazy looking examples of the derivatives to use. And it's very important that you use the u substitution and the regular chain rule. So it's good to understand both methods. Once you understand both methods and you can apply them, it'll make your life a lot easier. But remember, keep it simple, write neatly, keep everything spaced out so you can identify exactly what goes where. Because the main problem I found with students in this section is just mixing up what goes in the correct place with something that's just plainly wrong. So on the website, I have some more difficult examples for you to check out under the chain rule section. Alright, this is Seeing Calculus. If you understand everything in this video and you're ready to move on, go right ahead. See you.